Hello. In this lecture, we are going to be covering the endocrine responses to resistance exercise. So when we think about the goals of the endocrine system, again, the job of the endocrine system is really to function as a communicator. And so the way in which the endocrine system will work as it relates to resistance training and exercise training in general is it's going to serve as a communication system that's going to work a little bit slower than what we see with the nervous system. However, it's going to have maybe longer lasting effects. So again, what are some of the jobs as it relates to the endocrine system specific to exercise? It's going to help us to maintain homeostasis, coordinated communication within the body. It's going to play an important role in the human body as it relates to changes and support for the exercise demands, as well as assist in that recovery process. Okay, so when we think about how does this relate to periodization, for example, again, periodization of training is highly developed due to endocrine changes seen within the exercise. So again, when we think about how does this fit into our scheme as maybe strength and conditioning coaches, personal trainers, things like that, remember that when we think about adaptations to this system, we're really only talking about I don't want to say the top athletes, but people that are extremely consistent in what they're doing. Okay, so again, when we think about how to get somebody to maximize their endocrine response to exercise, I'm really targeting individuals that are doing all the things. They're doing all the things that they need to do to set themselves up for success in terms of they're not missing workouts, they're consistent with all of these types of things. So really think of a probably a small percentage of our population, but this would be kind of our bread and butter when we think about working with people in a strength and conditioning realm. So first thing we want to do is kind of take a look at how the endocrine system works and kind of have a short review in terms of how this will all fit together once we kind of review some of the endocrine glands and the hormones secreted from each of those glands and maybe how those might be influenced by the exercise stressors that we undergo. So this image shows you kind of all the endocrine glands within the body. And again, if you remember back to anatomy and physiology, kind of how does this system work? So each of these glands, which are spread, let's see if I can get my little pointer here, are spread really kind of all over the body. If we look at all these different locations where you can see different glands, and they're going to release a hormone, and that hormone is going to be dumped into the blood, and it's going to travel throughout the body via the blood, and it will only bind to and only affect cells or target tissues that have a specific receptor. So even though, for example, the thyroid gland, let's say, is going to release a hormone known as thyroid hormone, it will only have an effect on specific tissues that have a specific receptor available for the thyroid hormone to bind to. So when we think about, some of the adaptations that we experience with chronic exercise, we might be able to upregulate those receptors. Those receptors might become higher in quantity, so we might gain more of those. They might be more sensitive to a smaller amount of hormone. Those are some of the many adaptations that we might make as it relates to the receptors, as it relates to the hormones itself and how they're released. Maybe we are releasing a greater quantity of the hormone. Maybe we're releasing that hormone at like greater frequency as well. So lots of factors might play into how those hormones are released, how and when, how much, and then also think about those target cells. How are they affected with chronic training? So we might see, like I said, an upregulation of the receptors in some sort of way. And again, I would say that's probably the more common adaptation that we'll kind of talk about in a little more detail in this lecture as we kind of move forward. So now I'm not going to be like all encompassing when I talk about the hormones in the endocrine system. So if you feel like you need a refresher on some of the details related to those hormones and what they do, please go back to anatomy and phys and kind of review that section, whether it was in your notes or a lecture or whatever it is. I am going to kind of briefly go through some of the functions of some of the hormones that I find to be really important and really applicable to this section as it relates to strength training. So the first of the endocrine glands that we'll kind of hit on in this unit is the pituitary gland. And the pituitary gland, you can kind of see, is located under the hypothalamus. And it's kind of right here, I guess, inferior and posterior to your frontal lobe of the brain and superior to the pons and the brainstem. Okay, so it's technically located under the brain, but it's really connected to the brain, as you can kind of see here. And there are two different regions. We have the anterior lobe, which is kind of shown down here, and the posterior lobe here. The posterior lobe is sometimes called the neurohypophysis, and the reason for that is there's a lot of neural connections from the brain to that posterior lobe. Okay, the anterior lobe will be more endocrine based in nature and less, I guess, direct neural communication. Okay, so again, the anterior lobe is made of glandular tissue. It's going to secrete hormones, including growth hormone, thyroid stimulating hormone, ACTH, MSH, FSH, LH, and prolactin. And I have a chart on the next slide that'll kind of show you those hormones, and we can kind of fill in their target organ and effectors here coming up. As I mentioned, that posterior lobe is made of neural tissue, and it'll secrete ADH, which is antidiuretic hormone, vasopressin, and oxytocin. Again, it's structurally considered a part of the brain because there are axons that are going to reach down from the hypothalamus into that posterior lobe. So it doesn't necessarily make hormones here, but it does store and release hormones that are made from the hypothalamus. So as I said, when we look at the pituitary gland, we've got a ton of hormones coming from that anterior side. So here you can see the list of those anterior lobe hormones, and we can kind of fill in both their target organ and their effects. So again, their target organ, again, growth hormone will be released from the anterior pituitary. It'll flow into the bloodstream and kind of flow throughout the entire body, but it will only have an effect on the target organs that have those receptors that will accept that particular hormone. Okay. So what are the target organs with growth hormone? Again, growth hormone is one of the most important hormones that we'll speak about when we talk about strength training and how we can create adaptations within the system. Growth hormone does what it says it does, right? It's going to promote growth within the body. Really an important part of development for adolescence, childhood, and those types of things. So you're going to have high levels of growth hormone when you're growing. Once you reach adulthood, those levels will kind of dip down a little bit. Target organs, again, for the growth hormone include the liver, muscle tissue, bones, and cartilage. And again, the major job or the effect of growth hormone is to increase protein synthesis. Now, certainly this is a very, very important component when we think about growth as it relates to, just general development. However, this is going to be really important if we're interested in restructuring or modifying muscle tissue as well, or if we're interested in experiencing muscle growth, the growth hormone will play an important role there. Let's see, quickly through thyroid hormone, or I'm sorry, thyroid stimulating hormone. So anterior pituitary will release thyroid stimulating hormone. Thyroid stimulating hormone's job is to tell thyroid hormone what to do or to when to be released. So our target organ is the thyroid gland, and the effect is to cause the release of the thyroid hormone from the thyroid gland. So again, just think of this as like a cascade of events. The only thing that's happening with thyroid stimulating hormone is we're causing then the release of thyroid hormone. Okay. ACTH is another important one when we think about exercise. And this is going to stimulate the adrenal cortex. And I have another slide that kind of goes through the details of the adrenal cortex and the hormones that are coming from there. But this is going to cause the release of androgens and glucocorticoids, which are going to help us to deal with stressful situations, such as exercise. They can also help us to save carbohydrates or spare carbohydrates, sometimes it's called. Carbohydrate sparing for the brain. The brain can only function on carbohydrates. So if I have a limited amount of carbohydrates, I have a limited amount of sugar available, then I don't want to waste that on my muscles. I need to save that for brain function. So it's going to, when we're in a period of starvation, for example, or we have a limited supply of sugars available, like in weight loss, sometimes this can happen. We're going to release ACTH as a way to help us hold on to the carbs. We're going to save those for the brain, and it's going to force all the other areas of the body to rely on fats and amino acids for fuels. So as you might remember from what we've kind of discussed with metabolism and exercise physiology, you will already know that if I only have fats and if I only have amino acids, and we think about how that relates to exercise, our exercise intensity will automatically be decreased. So if we are having to spare those carbohydrates for the brain alone, this is going to have a major hindrance on our ability to do muscle work because we've got to back off to that oxidative pathway in terms of utilizing fats and amino acids. Quickly going through these, I wasn't going to include all the hormones in this lecture, but I'm almost regretting that a little bit because the endocrine system is so important, and I think it's often overlooked when we think about how all of these factors are layered and how all these things are interrelated when we think about exercise stress, we think about chronic training, but also thinking about it as it relates to creating a deficiency of energy. And how does that impact our general functioning? So you think about like weight loss, but also like eating disorders and things like that. How are some of these elements going to be manipulated and affected in a negative way when we put ourselves into what our body would consider a dangerous state? I really think this is fascinating when we think about all that's going on kind of behind the scenes under the surface as it relates to the different stressors that we provide to the body. Anyway, follicle stimulating hormone, what's this guy going to do? His target organ will be the ovaries for our ladies and the testes for men. And the job of follicle stimulating hormone is to stimulate sperm production for the men. And I would say this kind of works as a supply demand type of situation. So the release of follicle stimulating hormone isn't necessarily cyclical in men because it's related to the supply and demand of sperm basically. So again, you've got like a storage bank of sperm, and once those are released, we've got to produce more. So the frequency of the release will in part determine the frequency of release of this particular hormone. For the ladies, though, however, follicle stimulating hormone, as I said, is going to stimulate the ovaries, and this is going to cause the maturation of a follicle during the menstrual cycle. So ideally for women, this is very cyclical. So we should have a nice cyclical release of this hormone kind of once a month. And again, we'll see a spike in this for about 3 days or so. That's going to allow us to have that follicle selected and released for ovulation each month. And again, ideally, this hormone should be kind of steady in that regard in terms of having a spike and then decreasing back down, and then getting ready for the next month, same gig, having a spike and then decreasing back down. So that's the gig with follicle stimulating hormone and the differences for men and women. Luteinizing hormone is another one that's important for the reproductive systems. And this one will stimulate ovulation in females and promote testosterone production in the males. So again, our target organs will be ovaries and testes, and luteinizing hormone with the ladies is going to kind of be in line with what's going on with follicle stimulating hormone. So again, we want to have this just nice little spike. So basically, without getting into too much detail, the FSH is going to cause the one follicle, which you're going to release during ovulation, to prepare itself. And then luteinizing hormone, which is going to kind of work in concert, is going to cause that egg to be released from the ovary and flow down that darn fallopian tube so that you are ready to become pregnant or get rid of the egg when it becomes that section of your menstrual cycle. So that's what luteinizing hormone does for the girls. For men, it's going to promote testosterone production. Again, our goal is to, or our target organ here is the testes. Now, this is a little bit fuzzy, I would say, because this isn't necessarily supply and demand. We are going to talk about some ways in which it's possible that we could enhance our testosterone levels. We do know that there is a huge range in males and in females in terms of what we would consider normal hormone levels as it relates to testosterone. Now, if we backtrack from testosterone, because as we'll find out in this lecture, super important when we think about potential strength gains, muscle size, absolutely, and some of those factors that might be related to sport performance. But if we kind of backtrack up, is luteinizing hormone a really important element in how much of that testosterone we're creating or we're producing? Yes, absolutely, 100%. Then lastly, prolactin is the last of the hormones in the anterior pituitary, and this is going to promote lactation in female breast tissue after a baby is born. So our target organ is the female breast tissue, and again, we would only release this hormone if a mother is breastfeeding. And this hormone will work on kind of a negative feedback loop. So again, really supply and demand will allow us to keep producing prolactin. So if you're like breastfeeding, you'll continue to produce milk as long as baby is taking the milk, sort of thing. And so then, like, if you wanted to stop doing that, then you would just kind of like wean off, and it would, it's just going to match its supply and demand. In theory, that's kind of how that works. So again, I wouldn't think men can even produce this. And like I said, women will only have this if they are breastfeeding. So no other times would we release that. Okay, the next endocrine gland we're going to take a look at here is the thyroid gland, which you can see is kind of located in your neck. It's kind of here anteriorly. Ideally, you have, a couple different lobes here, and we're going to release two different hormones. Number one is the thyroid hormone, and number two is calcitonin. Let's talk about some of the details related to the thyroid gland, because thyroid gland is super important when we think about certainly exercise performance, but weight management as well, because the thyroid hormone is in charge of kind of our overall general metabolic rate. So target organ, when we think about thyroid hormone, it's kind of all encompassing. So it's going to have an all encompassing effect on the body. And its main job is to increase, or I guess monitor, the basal metabolic rate, or our resting metabolism. Individuals with high thyroid hormone will be hyperthyroid, so they're going to be more likely to be like kind of energetic. They're going to be hot all the time. They will have no issues like losing weight or maintaining like a lean kind of physique. People that have low thyroid hormone will be cold, sluggish. They might be overweight or be more apt to gain weight. So that's kind of interesting. Calcitonin is related to monitoring our blood calcium levels. So calcitonin is released if the blood calcium is too high. And again, this is less important in adults, probably more important when we're kids and we're trying to have substantial bone growth. But again, it's released if blood calcium levels are too high. And if blood calcium levels are too high, then calcitonin is going to kind of do some different things to help us get those calcium levels out of the blood. So it might be excreting calcium via the kidneys, or we can have bone breakdown through the osteoclast kind of slow down a little bit. And those are kind of the target things that we want to do with that hormone, that calcitonin. Okay, now we got adrenal glands. Adrenal glands, very, very, very important when we think about exercise and exercise stress and kind of the chronic effect of exercise stress. But these adrenal glands are going to sit kind of right on top of or on that superior portion of the kidneys. And there's two different sections of the adrenal glands. So we have the adrenal cortex, which is like this outer section. And then we have the adrenal medulla, which is this internal section here. Okay. And so generally speaking, we'll break up the hormones into each of those sections of the adrenal gland. As I said, the cortex, which is found on the outside, will release something called corticosteroids, such as aldosterone and cortisol. Aldosterone's job is to help us conserve water through the retention of sodium in the kidneys. So again, we would release aldosterone when we're doing exercise, particularly aerobic exercise, to kind of help us maintain our fluids so that we can save them for sweating instead of peeing them out. Cortisol, very, very important when we think about stress over time. Cortisol is going to help the body cope with stress by stabilizing blood glucose levels and inhibiting inflammation. So again, really, really important when we're doing some types of chronic stress. The adrenal medulla, which again is kind of that internal portion here. The adrenal medulla will release epinephrine and norepinephrine, also known as our adrenaline. And this will be felt when we have a sympathetic nervous system stimulation in a fight or flight situation. So again, anytime we are feeling like threatened, and again, the interesting thing about this is your body can't differentiate between like a physical stressor and an emotional stressor or a cognitive stressor. So your body kind of responds the same to all of those things. But basically, epinephrine, norepinephrine are kind of these adrenaline types of things that are going to help us like it like blocks some of our pain receptors, so it'll prevent us from feeling pain. But they're also going to do a lot of other things to maybe like send more blood to the muscles and make us feel good, which is one of the reasons why people like me are addicted to exercise, is because you get this feel good, you get this good feeling when you do it. And that's related to the release of epinephrine and norepinephrine. So the next of the endocrine glands we want to take a look at is the pineal gland, which is located kind of in the midbrain area here. And this will be responsible for releasing melatonin, which is going to help us to kind of monitor our circadian rhythms or kind of our sleep-wake cycle. Again, when we think about how this relates to training and chronic training and how this can be modified and adapted, I would say regular exercise is going to allow us to gain quality sleep and things like that in terms of how much melatonin is released. Again, if I'm doing something rigorous and I need to recover, I will, feel more fatigued and get a higher quality of sleep out of that. Now, the other thing that I think is interesting about this, and one thing I really wanted to point out, is the importance of maintaining a good circadian rhythm and how important that is in terms of our recovery from exercise and how we can utilize a good circadian rhythm to allow ourselves to kind of continue improving at a, dare I say, faster rate than someone who's not kind of maintaining that regular circadian rhythm. So I think that is an area for college students that, we really struggle with, is kind of maintaining, go to bed at the same time every night, wake up at the same time, to create this sleep wake cycle where you're getting the most out of your sleep. And again, if you're doing that, Monday through Thursday, and then on Fridays or Saturdays, you're out till 2 a.m. and then you sleep until 10 and you were drinking. And so then your circadian rhythm, you're not getting good quality of sleep. And then, that's going to set you back for a couple days as you kind of recover from that. So then you have, so it's just this whole cycle in terms of not having quality sleep wake cycles and creating that kind of constant good REM sleep. So I think that that is something to definitely note. Now, I think the other part to kind of keep in mind is, at what expense, so it's like, yes, I want to have good sport performance, but I also don't want to miss out on the social aspect of college, or, if we're even talking about high school, being able to be out with your friends is a huge part of it. So I think it's important that athletes know the importance of that, but then, in my opinion, you kind of leave it up to them in terms of, okay, how important is sleep to me in comparison to these social aspects, or even, work schedules as well, not even social, but like if I have to work, I'm a bartender, or I'm waitress, or maybe I have to get up early to go to work, or whatever the case may be, doing our best to maintain this is huge in terms of weight management. It's huge in terms of seeing good gains with strength training and, any type of chronic exercise training. So I think that we undersell that to people. And I think that that's something that's an important element to really think about when we're working with athletes or general population who are looking to make exercise gains or weight loss improvements. Okay, so here we've got the gonads again. This will include the testes and the ovaries. So the ovaries you can see here for the ladies that are going to lead to the fallopian tubes and to the uterus. And then the cervix would be the exit of the uterus here, which would lead out into the vagina. For the men, the testes and the epididymis you can see here, which would allow us to have sperm formation. Epididymis is going to allow us to have that sperm exiting. But again, our major players as it relates to hormones are testosterone, estrogen, and progesterone. And you think about these as important indicators for reproductive health, but really they're great indicators for us of overtraining. And also, as you probably already know, testosterone can play a huge role for us as it relates to muscle gain and recovery from exercise. And certainly on that anaerobic side of performance, testosterone will play a really important role. So the other thing that I think is maybe a common misconception is that men have testosterone, women have estrogen and progesterone, which is true, but really in reality we have all three of these things. So men are going to have estrogen and progesterone as well. Women will have testosterone. And interestingly, you think about like the ethical debates of what is considered normal levels. Interestingly, for women, estrogen and progesterone levels, what is considered normal for you and would allow you to maintain a normal menstrual cycle, varies substantially from person to person. In general, again, this is just a generalization, highly fit women will have lower estrogen and progesterone levels than kind of like your average sedentary female. That doesn't mean that their fertility is compromised, but just in general, we can look at those hormones as it relates to like weight or body fat percentage. So for example, the more estrogen I have, the greater the likelihood that I store fat in my hips and thighs area. And again, that's a genetic predisposition there. But so you would see kind of some of those elite women having lower levels. And again, then it would make sense why their body composition is going to be lower. They're going to be more lean because they have less of that hormone. When we think about testosterone, again, more testosterone would be beneficial for muscular gains and also anaerobic performance. And that's true on both the men and women's side. And the reason for that is, again, testosterone is going to help us kind of enhance muscle growth and the potential for muscle mass. Also, we see the same thing when we look at aerobic activity as well, because testosterone is going to promote the production of red blood cells, and that would help us from an aerobic perspective. So big players here in terms of sport performance, absolutely. And when we think about testosterone, really a big player when we think about how does this relate to strength and conditioning, and we'll talk more about testosterone here coming up. So when we think about, this in general, muscle as the target for hormonal interactions, again, we said that those hormones are going to travel in the blood, and then they're going to only affect some of those target organs that we talked about. Muscle remodeling involves disruption and damage of the muscle fibers. When you do lift, you're going to experience an inflammatory response. We'll see degradation of those myofilaments or those myofibrils within a muscle cell itself, causing degradation of those damaged proteins. And then we're going to have hormonal and other signaling interactions that are going to allow us to not only fix what you've kind of broken down, but also to build those up stronger than what they were before. So again, the idea with strength training and the soreness that you experience is that the hormonal cascade that will occur afterwards will ultimately result in new proteins. And the idea with that is that we want those new proteins to be even better than what they were before you kind of tore them down. So when we think about hormones that are going to be important for this, certainly we know that the anabolic hormones, and anabolism means to build up. So anabolic hormones are going to contribute to various parts of this process. Certainly thyroid hormone, as it relates to metabolism, will play a permissive role in this process. And also we're going to have the blocking of catabolic hormones, and catabolic hormones are going to cause the breakdown of muscles. So during that recovery process, again, we want to stimulate more protein synthesis, and so therefore we might experience the blocking of catabolic hormones and the increase in metabolic rate, which would allow us to improve protein synthesis. So how does heavy resistance exercise affect hormones in general? Long-term resistance training, so we're looking at chronic exercise, maybe it's months to years, will cause substantial changes in the endocrine system. So again, it takes some time for us to see these processes begin to change, and it's really about consistency. When we think about certainly sport performance, but also weight loss and those types of things, it's all about consistency, and it's all about creating a habit and sticking with that habit, sticking with whatever that routine is, so that we can kind of see those chronic changes over time. So essentially, when a motor unit is stimulated, various signals are sent from both the brain and the activated muscles to a number of endocrine glands. So acute hormonal secretions provide information about the amount and type of stress. Okay, so again, how vigorous is the stress? What is the type of stress? Is it resistance training? Is it aerobic? Is it more flexibility based? So any of those stressors that we provide, we want to send information about how is it stressing the muscles. Number two is metabolic needs of the exercise. So again, how long and how intense are certainly part of that equation, but also the mode of exercise would play an important role. And then number three, what metabolic changes need to be made. And when we think about what metabolic changes we need to be made, certainly we need to understand those metabolic pathways and how we might stimulate those, but then also in the recovery process, how do I clear out the lactate? How do I clear out those hydrogen molecules to get rid of those? So again, these hormonal changes, the substantial changes that we see within the endocrine system, can cause increases in size, strength, and power of musculature. The type of exercise protocol activated determines the extent to which the systems can improve, right? So again, we're going to talk about the various stipulations that you should follow if you're interested in power, if you're interested in muscular endurance, if you're interested in hypertrophy, for example. And again, the idea with these protocols is that we want to maximize the endocrine response so that we can kind of maximize the change associated with that particular stressor. Hormones can actually also be released before exercise in an anticipatory response and after the exercise due to the stress provided from that resistance training exercise bout. So we're talking about heavy resistance exercise. Again, we're talking about like high intensity, kind of some of that strength-based training or hypertrophy-based training. So during heavy resistance exercise, the large force production causes alterations in the sarcolemma's ability to import nutrients. Changes in sensitivity and numbers of hormone receptors in the muscle cell can also occur, which would allow us to create more receptors. Okay, so essentially if like testosterone, for example, is going to bind to an androgen receptor. The more resistance training I do, the more of those androgen receptors that I have. Okay, so as few as 1 to 2 resistance sessions can increase the number of androgen receptors in a muscle. So again, we think about these chronic changes that we're experiencing. And I'm here to tell you that it's as little as 1 to 2 sessions where we're starting to see some of these positive changes occurring. And when we think about aerobic exercise, same gig, as little as 3 to 6 exercise sessions, and we're starting to see chronic changes from positive adaptation perspective. So this is huge. I think that, it's never too late to start, and certainly doing something is always better than doing nothing. So we think about how quickly our bodies can begin to adapt to stressors. Like, that's absolutely insane. 1 to 2 sessions, and we're starting to already upregulate from an endocrine perspective. Following the exercise, tissue remodeling and repair can occur based on the amount of time and the amount of tissue that is stimulated during that exercise bout. So what are the mechanisms of hormonal interactions? The sensitivity of cells to a particular hormone may be altered in a few different ways. So if a muscle cell has already reached its maximum size with long-term training, it might not be as sensitive to hormonal signals to stimulate further protein growth. So what we're saying here is we kind of all have some sort of ceiling. So there is a ceiling as it relates to strength and size kind of limitations, we'll say. So there is certainly a genetic predisposition that will most likely determine when you've kind of reached whatever that ceiling is. Receptors can also become desensitized when resting hormone levels are chronically elevated due to disease or drug use. So again, the use of like anabolic steroids, for example, or some of those kind of like anabolic agents can cause an influence on the resting hormonal levels, but also causing those receptors to become desensitized. When you're training highly trained individuals, they're already closer to their ceiling, as you might imagine. And so they're going to have a harder time seeing just those minute improvements in comparison to, other individuals, maybe more like beginners, right? So some examples of disease. So type 2 diabetes, as we've kind of talked about in exercise physiology, certainly play a role in the responsiveness of these receptors as it relates to hormones. As it relates to hormonal changes in the blood, hormone responses are tightly linked to the characteristics of resistance training exercise protocol. We can learn about the physical stress of a workout by monitoring biomarkers in the blood. Now, certainly this only tells us part of the equation when we think about, how much is being produced, how much is being uptaken, and those types of factors. Hormone concentrations can be measured during various stages of exercise and exercise training. Now, also keep in mind that some of our hormones are released in kind of like a pulsatile way. So, when you measure that in the blood, can really give you varying results based on when like that pulsatile, like it's like a whoosh, kind of like when your heart contracts, like you send a whoosh of blood and then you send a whoosh of blood. Hormones some of them can kind of work that way as well. So that gets a little tricky when we think about measuring hormonal levels within the blood. So it's a little iffy there. If we see an increase in blood concentration, this doesn't necessarily mean an increase in muscle size, but it does indicate that we've increased activation of the endocrine gland. So again, we've got to do the right things in order to stimulate muscle breakdown in order for us to appropriately be able to kind of build things back up. So as it relates to adaptations within the endocrine system, when you train skeletal muscle, you're also training the endocrine system. The level of endocrine involvement is directly related to the support needed by the activated motor units. So what is this dependent on? Certainly the toleration of exercise stress, but also on the amount of muscle mass you're activating. So basically, you need to activate as many large motor units as you can and cause a substantial amount of damage to maximize your endocrine response. So what are the possible endocrine adaptations? Number one, amount of synthesis and storage of hormones. So again, we can think about how much, so the amount, time needed for clearance of hormones in the liver, how much blood to tissue fluid shift occurs with that exercise stress, how many receptors are in that tissue, and the degree of interaction within the cell nucleus. Again, these factors together will dictate how much protein is synthesized. We think about the primary anabolic hormones. This will include testosterone, growth hormone, and something called insulin-like growth factor. So let's start with testosterone. Again, testosterone can promote growth hormone release from the pituitary. It can also interact with receptors on the neurons, which will increase amounts of neurotransmitters and influence structural protein changes. Therefore, it can cause an increase in muscle mass of the innervated muscle and the force production potential. So again, that potential means that you still have to do the work in order for it to be activated and in order to have that occur in a coordinated way. Heavy resistance training using 1 to 2 repetitions in low volume may cause an increase in testosterone receptors. So again, we're talking like 95% intensity, rep or sets of 1 to 2 reps. We want really a long rest period so that we can get kind of reach that highest quality that we can. And this would help us to improve the amount of testosterone receptors that you have. Again, remember that this is very specific to the muscle mass activated. So if I want to stimulate protein synthesis in my legs, I got to do it in my legs, right? We can also increase the peripheral testosterone levels, particularly in men following high intensity aerobic exercise and resistance exercise. So again, we already mentioned that aerobic exercisers or endurance exercisers will benefit from high testosterone levels due to the red blood cell production probability associated with high testosterone levels. Again, testosterone concentrations have some diurnal variation. So what does that mean? It means that it's going to be cyclical throughout the day, just kind of like that sleep-wake cycle. And so, those are going to be diurnal if we were to measure them at various times. That's kind of what that means. What's going on behind the scenes here? We need to increase testosterone levels in the blood and also increase their binding as well. So we need to produce more, but we also need more receptors so that we can respond to testosterone with greater precision. Endurance exercise causes catabolic activity. So, if I'm doing a lot of kind of that aerobic work, it can cause the breakdown of muscles. So this is a way to combat that and not increase muscle size. So what I'm saying is if I'm an endurance athlete and I don't want to lose muscle mass because I'm doing a ton of volume, right? So I'm running a ton, I'm biking a ton, whatever it is, okay? Then by doing kind of this heavy resistance training, the idea here is not necessarily that I would be increasing the muscle mass that I have, but by doing heavy resistance training, I'm able to combat the potential of muscle loss associated with a high volume of aerobic exercise. Okay, so those diurnal variations are normal fluctuations in those hormonal levels throughout any given day. So I think I've got an image of that coming up. Okay, so does this affect when you should strength train? So here you can see those diurnal variations in testosterone levels throughout the day. Again, the highest levels are kind of early in the morning, and then they're going to drop progressively throughout the day. And it turns out that the time of strength training doesn't affect these total testosterone levels, the diurnal pattern, or the absolute increase in maximal strength. So at the end of the day, doesn't matter when you resistance train, you can do it in the morning, night, whatever. I would say whenever you can create the greatest stressor for yourself, but also you got to think about the practicality of fitting it in, right? So if I only have mornings available, then mornings are the best time to strength train. If I have the choice and I can do it whenever, but maybe I can give a better effort if it's evening or afternoon or whatever, then that works as well. So again, doesn't really matter as it relates to strength gains, what time of day you're doing the strength training, even though we're seeing kind of these peak testosterone levels kind of in the morning, earlier in the day. What about in women? So again, as I mentioned previously, women also have testosterone levels, but we have 15 to 20 times lower testosterone levels than men. Small but significant increases in testosterone can occur in women with resistance training. So again, we're looking at 6 by 10 squats. So again, 6 sets, 10 reps. Again, we need high intensity or a high percentage of 1 RM in order to stimulate testosterone increases. Some studies have been unable to demonstrate changes in testosterone levels in women. However, we probably do experience an upregulation of testosterone. So what does that mean? Even though you only have the same quantity, you're able to get more bang for your buck, essentially, when it comes to the effects of the testosterone that you do have. Again, testosterone levels can vary substantially between individual women. So we know that there's a really, really large range there. I would say that in general, if we were to look at kind of those anaerobic, those sprint females that are very elite, they will probably naturally have higher testosterone levels than kind of your average person. And again, maybe that's what has allowed them, at least in part, to be an elite athlete, is kind of having those naturally or that genetic predisposition to have higher testosterone levels. We think about training adaptations of testosterone. Not much is understood about the chronic responses of testosterone related to resistance training. We know that an increase in exercise-induced testosterone concentrations due to improved functional capacity is likely. So again, we believe that if we were able to increase testosterone levels, then we would likely improve our functional capacity. Research is actually mixed on testosterone changes with chronic training. So again, some of the questions in the research that are currently being addressed: do resting testosterone levels change substantially? Does receptor density change? Are receptors upregulated? So again, those are kind of the three possibilities when we think about testosterone and its role as it relates to improving muscle strength or muscle size, as it relates to chronic strength training. Growth hormones, pretty hot topic in strength training research right now. We're just starting to understand the complexities of not only growth hormone, but also its binding proteins. So again, we've talked about kind of these target receptors and kind of, the binding of growth hormone in these different locations is going to cause different changes within different types of cells, essentially. So it is pretty complicated, particularly when you think about something like growth hormone that's going to affect the bones, the tendons, the muscles, so it's got its hand in a lot of different things. Growth hormone, as you know, is an important part of development as a child, but it also is an important element when we think about adaptation to stress as it relates to resistance training. We believe that there's a positive correlation between growth hormone responses and muscle hypertrophy if you're doing a minimum of 20 weeks of resistance training. And again, this was done through a regression analysis. So we do believe that growth hormone is playing an important role as it relates to kind of this chronic change in hypertrophy or muscle size changes associated with regular resistance training. So this I think is just interesting. I love cascades. I love science. So here you can see we've got the pituitary up top. We've got hypothalamus, which is going to secrete growth hormone releasing hormone, the growth hormone releasing hormone up here. And that's going to stimulate the release of growth hormone, and this will occur through a feedback loop. What happens when we stimulate or release growth hormone? It will have direct actions as it relates to metabolism. It will affect fat and carbohydrate metabolism. Okay, so carbohydrate metabolism will see an increase in blood glucose levels and other anti-insulin effects. So again, insulin's job is to store sugars, and when I'm releasing growth hormone, again, I want to use those sugars, so we're going to increase the amount of sugars that we have in the blood. As I increase metabolism, I'm also going to see an increase in fat breakdown and release as well. When we think about the benefits of this from a weight loss perspective, again, another nice selling point for us, that If we're doing chronic resistance training, if I stimulate growth hormone, I am going to increase the fat mobilization potentially. And therefore, when I'm done with the exercise bout, I'm able to burn more fats. And so maybe that's going to help me modify my body composition by burning fats after the exercise is over. You know that during the exercise, we're only using carbs if we're doing high intensity resistance. What are some indirect actions that we see with growth hormone? We'll see it affect the liver, for example. And also we've got insulin-like growth factors that's going to play a role in the skeletal system. So again, looking at improving cartilage strength potentially, also the stimulation of the bone when muscle contracts and we do weight-bearing activities. So we'll see some skeletal growth. Extraskeletal, again, this is probably what we're most interested in. This is our biggest bang for our buck when it is related to muscle size, muscle strength, those types of things. We'll see an increase in protein synthesis, cell growth, and proliferation when we stimulate growth hormone as well. So what's going on with this? Again, growth hormone is released as a result of a variety of stressors, including resistance exercise. Again, got to be high intensity. We've got to be close to that 1 RM. Hypoxia is another reason, and hypoxia is when I don't have enough oxygen. So again, if I'm doing maximal exercise where I'm not getting enough oxygen, that can stimulate growth hormone release. We're also seeing like occlusion training. I'm not sure if you've heard of this before, but basically like if I wanted to do occlusion training of my like bicep, for example, let me see if I can figure out how to get this in front of the screen here. If I can occlude blood flow, there we go. If I can occlude blood flow like at my shoulder, that would stop blood flow from flowing into my bicep. And then by doing exercise here without blood flow, that in theory should allow us to release more growth hormone, and that can cause greater changes. The tricky part with like the occlusion training though is like, okay, well, I can do it up here so that it affects like my bicep, but like, how do I do that for big muscles? How do I occlude blood flow from like my glutes, for example, or even my hamstrings? Pretty difficult to do that. But in theory, like it's a great idea because of this growth hormone stimulus. We see an increase in hydrogen as well. Again, we'll see hydrogen increase when you do anaerobic glycolysis, and we've got the waste product buildup there. So again, high intensity, really any type of high intensity exercise is going to stimulate growth hormone release. What's the best bang for your buck? We can do hypertrophy training. So this involves 10 reps, 3 sets with a short rest, less than 1 minute, and that's going to promote muscle hypertrophy and also promote the greatest growth hormone response. So what about in women? Is this different in women? So again, growth hormone concentrations are highest during the menstrual phase, although mechanisms for this are unclear. We don't know why. Maybe it's something like as we're shedding that endothelial lining, the body's kind of trying to prepare or recover from that so that you're ready for the next portion of the menstrual cycle. Although now that I say that out loud, then I think that the proliferative phase of the menstrual cycle would have the greatest growth hormone levels, but again, not sure what the mechanism is here. So that's an interesting question. I mean, should women train differently? Should women try to do something differently during these different phases of their menstrual cycles, kind of based on these changes in hormonal levels? It's certainly a concept to think about. You've got to have really an elite athlete if you're really monitoring that closely. I would say for most of us, it's just a matter of doing the thing and doing the thing consistently and that sort of element. But again, maybe with elite women, we can get down to the nitty-gritties of that. Again, we need to do resistance exercise with short rest periods, so 1 minute of rest or less, and that's going to increase growth hormone, just as we mentioned with men in the previous slide. The use of estrogen-containing birth control pills actually appears to elevate growth hormone response with resistance training. However, you do run into issues in this case where we've got to think about the use of those estrogen-containing pills and how that affects fat storage. And again, more estrogen means more fat storage for the average person. So you got to think about who that's most appropriate for. So to be determined, should women use a periodization model for resistance training based on their menstrual cycle phase? In theory, that seems great. However, if I'm working with a full team and I've got 3 different teams that I'm working with at any given time, I'm working with women's basketball, I'm working with wrestling, and I'm working with the swimming and diving team. I can't individualize every single plan. So as a true strength and conditioning coach, like that's just not feasible. Again, if I'm a private personal trainer and I'm working with elite athletes, yeah, it's something to think about in terms of, what we might need to do in order to set them up for their greatest potential for gains. So when we think about training adaptations here, growth hormone is released again in a pulsatile fashion. I mentioned that previously when we were talking in general about hormones, but yeah, it's like basically like a whoosh every, I don't know for sure how often, maybe it's every 90 seconds, or something like that. So anyway, it's hard to track those changes that might occur during resistance training because those levels vary so much, based on when you measure the blood. Changes in growth hormone receptor sensitivities, diurnal variations, and maximal exercise growth hormone concentrations will likely occur with chronic training. Seems as though the more elite you are, the smaller the changes are. Of course, you know that. The closer you kind of are to your true ceiling, the smaller those improvements become. But overall, it's still unknown how growth hormone changes with long-term resistance training. Okay, so we mentioned insulin-like growth factor, and just a few things to note about this. What's it do? It's going to stimulate systemic body growth and has its growth-promoting effects on skeletal muscle, cartilage, bone, liver, kidneys, nerves. Again, really works in concert with growth hormone. It can regulate cell growth and development as well. There are 6 different binding proteins for IGF within the blood. Each binding protein responds to exercise stress independently and its own biological actions. So that's freaking cool. Nutritional status is also important when we think about insulin levels and how this kind of interplays with the IGF release. So again, when we think about this release, what is it affected by? Exercise stressor. So again, what are we doing? The adaptation or release of other hormones. So again, those things are going to kind of interact. And then binding protein availability. So again, as we mentioned, there's 6 different binding proteins available. How do I get more of those available? Well, it depends on depends on genetics. Certainly, it depends on what you're doing within that exercise bout as well. So when we think about the exercise responses of insulin-like growth factor, again, exercise causes this acute increase in IGF, and this will occur not only in the blood, but in the interstitial fluid and also in the muscle of those activated areas. So again, that's going to be very specific to the muscle mass that you've activated. These increases will be more pronounced when your resting levels are low. So again, kind of thinking about that hard, easy cycle and making sure we're fully recovered before we begin another hard exercise bout. Stimulation is 8 to 24 hours following the exercise bout. So again, a little bit delayed. At rest, fat cells produce the majority of the IGF, and with acute exercise, muscle cells will increase their release of IGF, having an autocrine effect. So again, basically what that means is that hormone is released from the muscle cell and it has an effect on itself. Response may be best when carbohydrate and protein supplementation occurs before and after that exercise bout. So again, when we think about these gains from a strength and hypertrophy perspective, nutrition is so key, and also sleep is so key in the recovery process and kind of how these hormones play a role. So what about the training adaptations associated with IGF? Chronic changes to IGF due to resistance training are variant within the research. So again, some are saying we can have chronic changes. Others are saying like, maybe not, maybe not. Caloric intake and baseline IGF levels play a huge role in those IGF changes over time. So again, one thing that I think is important to note is this hard, easy cycle. We've got to make sure we're recovering, and then we've got to go hard. So again, I think kind of balancing that, I think a lot of people end up kind of doing this moderate thing, kind of drudging along, and it really would be better if we could go easy, hard, so that we are really maximizing the hormonal response. So here you can see adrenal hormones. So we're taking a look at cortisol and the catecholamines, including epinephrine, norepinephrine, and dopamine. So here you can see the adrenal gland, which sits right on top of the kidneys. Again, the cortex is in the outer portion or that superficial portion, and the medulla is the internal portion or deep. So let's start with cortisol. So again, cortisol can act as a catabolic hormone within the skeletal muscle. So catabolic means that it's breaking down. Acts as a primary signal for carbohydrate metabolism and is related to those glycogen stores within the muscles. So again, it's going to help us to get the glycogen out of storage so that we're ready to use it as a fuel. This is diurnal as well, so it does have some rhythm to it with concentrations greatest in the morning. So again, we're going to see peak cortisol and peak testosterone levels early in the morning. What else is cortisol kind of known for? Again, it's going to help to break down those carbohydrates so that we can use them in the form of sugars or glucose. Can also convert amino acids to carbs for metabolism. Again, we don't want it to do that, but we can if we're not fueling appropriately. Also inhibits protein synthesis, so it can be catabolic in nature on those type 2 protein fibers, so on those fast twitch fibers. So again, this is certainly a stress hormone to pay attention to. So what happens during resistance training as it relates to cortisol? There's an acute increase in cortisol following exercise, primarily related to inflammation and tissue remodeling. The most dramatic increases when rest is low and the total volume of work is high. So again, we've got to think about that relationship when we are creating a hard exercise stressor. Cortisol levels may be monitored as a way to indicate overtraining. So again, if we see these kind of chronic levels kind of sneaking up, that's a bad sign for us. Cortisol to testosterone ratios may provide information about that catabolic or anabolic state of the body. So again, we're constantly breaking down, we're constantly building up, but we need to have more testosterone in order to build more than the breakdown that we might experience from that cortisol. So again, high levels are bad, or I'm sorry, chronic high levels of cortisol are bad, but acute increases are probably part of a larger remodeling process, which are good because they're helping to remove some of those damaged proteins. So acute high levels of cortisol are good. That shows us that remodeling is happening. Chronic high levels of cortisol are bad because that shows us that we're in a state of overtraining. So we think about these catecholamines. Again, research shows that those who have higher catecholamine release were able to maintain higher force output throughout the workout. Again, maybe the reason for that is we're blocking pain receptors. So again, the more of this catecholamine release I can experience, the more pain receptors I block. So therefore, I can maintain that higher force output. Epinephrine primarily, but also norepinephrine and dopamine will play a role in some of these factors. So central motor stimulator, peripheral vascular dilator, so allowing us to send more blood to the muscle itself. Enhance enzymatic activity. So again, we can kind of upregulate the processes that allow us to break down nutrients to use for those energy pathways, and induce calcium release in the muscle. We know that calcium is an important component of the sliding filament theory, so it's important that we have enough calcium available. More calcium means more of those binding sites are uncovered and more interaction of the actin and myosin molecules, meaning that we can kind of get a greater bang for our buck within the muscle during that functional movement, during that actual exercise session. What are the roles of catecholamines as it relates to strength training? We're going to increase force production, increase metabolic enzymatic activity. So again, kind of speeding up the rate at which we can break down the glucose into ATP in glycolysis and among those other energy systems as well. Increase muscle contractile rate. So again, we're going to increase the speed of that contraction, increase blood pressure, which allows us to deliver more oxygen, nutrients, get those wastes out of there a little bit faster. Increase energy availability. So again, getting sugars out of storage, putting them into the blood so that those glucose molecules are ready to be taken into the muscle and utilized. And then increase muscle blood flow. So again, that's going to kind of go along with that modification in the vasculature. So again, changing the diameter of the tube. So we'll see more vasodilation leading to muscle tissue that I'm using and less blood flow to like the stomach, the intestines, those types of places. So we think about training adaptations with these. Catecholamines are probably the first endocrine mechanism in response to resistance exercise, probably in response to any type of exercise, but the threshold for catecholamines can increase with training status. So that kind of sucks. Honestly, that's annoying. So you think about this idea of like a runner's high and how you like feel good, like you do a workout and you feel good and you're like, wow, I feel like I'm an Olympian, like today is great, like everything felt easy and I feel strong or I feel fast or whatever it is. Well, it turns out the more you do, the harder it is to get that feeling. So it is a little bit like addictive, right? Because now I have to do a little bit more to get that same feeling. And now I have to do a little bit more and a little bit more. So again, that threshold kind of goes up the more fit you become. Training protocols can be varied to allow the adrenal gland to engage in that recovery process. So when we have overuse, adrenal responses decrease, and hence there's a decrease in that catecholamine response, which means that you're going to do the exercise, and instead of feeling like, oh my God, I'm an Olympian, like I feel so good, this is amazing, instead, you don't feel like that. Instead, you feel like, this feels so hard and I can't wait to be done. I'm so tired. So a really different experience when you don't get that catecholamine release where you do feel good afterwards. Okay, when we think about how do we optimize hormonal release, I'm going to kind of help you fill in this chart here. So for testosterone, what's the exercise protocol? We should do heavy resistance training of 85 to 95% of 1 RM at a moderate to high volume. Our rest should be 30 to 60 seconds between sets, and we should use large muscle group exercises. Okay, for growth hormone, we're going to do 3 sets of 10 with heavy resistance. Rest should be limited to 60 seconds. Other things to note, again, supplement the diet with carbs and proteins before and after the workout to kind of upregulate or kind of maximize the usage of that growth hormone. And then lastly, those adrenal hormones, those catecholamines and cortisol. Again, we want to use high volume, large muscle groups, short rest intervals. And again, we want to provide those recovery days with lower workout volume to engage the recovery process so that we don't get overtrained. And I think that's it for today. I hope you guys have a great day and we will see you soon.